Welcome back to Raminfotech Data Recovery. In today's video, we're going to perform a complete data recovery procedure on an 8GB USB flash drive that has completely failed. The pendrive is not being detected by the computer, making normal software recovery impossible. When a USB drive fails, the problem is often caused by a damaged USB connector, controller failure, corrupted firmware, or physical damage to the circuit board. However, the actual data is usually stored inside a NAND flash memory chip. Even if the controller stops working, the data may still exist inside that memory chip. Our goal today is to recover the data directly from the NAND memory chip using a professional chip-off recovery method. Let's begin. First, we carefully inspect the pendrive. The outer casing is removed to expose the printed circuit board. On most flash drives, we can identify three major components: the USB connector, the controller chip, and the NAND flash memory chip where the files are stored. At this stage, we check for broken USB connectors, burned components, corrosion, cracked circuit traces, physical damage. Under magnification, the board appears intact, but the drive is still not detected by the operating system. This indicates that the controller may have failed while the NAND memory remains healthy. Before removing any components, we perform electrical diagnostics. The flash drive is connected to a test workstation. We check power consumption, USB enumeration, controller response. Unfortunately, the device does not enumerate correctly. The operating system cannot communicate with the controller. This confirms that traditional software recovery methods will not work because the computer cannot access the stored data through the normal USB interface. The next step is chip-level recovery. Now we identify the NAND flash memory chip. This particular 8GB flash drive uses a NAND memory package soldered directly to the circuit board. The chip markings are documented and photographed for reference. Knowing the exact NAND model helps us choose the correct adapter and recovery configuration later in the process. Every NAND manufacturer stores data differently, so accurate identification is critical. Next comes one of the most delicate stages of the recovery process. Using a controlled hot air rework station, we carefully heat the board and remove the NAND flash chip. The goal is to remove the chip without damaging the silicon die, the chip pins, the PCB pads. Professional recovery labs use precise temperature control because excessive heat can permanently damage the memory chip. Once the chip is safely removed, we clean the solder residues and prepare it for reading. With the NAND chip removed, it is installed into a specialized NAND reader. Unlike a normal USB connection, this equipment communicates directly with the flash memory itself. The reader extracts a raw memory dump from the chip. At this stage, the recovered data does not look like normal files. Instead, it appears as millions of pages of raw binary information. The original controller used complex algorithms to manage storage, error correction, wear leveling, and data mapping. These structures must now be reconstructed manually. The extraction process may take several minutes depending on chip condition and capacity. Now the real recovery work begins. The raw NAND dump is loaded into specialized recovery software. Several reconstruction processes are performed: error correction, EXOR pattern removal, block mapping, page ordering, file system reconstruction. These steps recreate the logical structure originally managed by the failed controller. Without reconstruction, the data remains unreadable. This stage often requires experience because different controller manufacturers use different storage algorithms. After reconstruction, the software begins rebuilding the file system. Folders start appearing, photos become visible. Videos, documents, and other user files can now be accessed. We verify the integrity of recovered data by opening several sample files. In this case, the majority of the data appears intact. This demonstrates why chip-off recovery can be successful even when a flash drive appears completely dead. The controller may fail, but the NAND memory often still contains recoverable information. Let's review the final recovery results. The recovered data includes personal photos, video recordings, documents, archived files. The recovered files are copied onto a new storage device for safe delivery. It is important to note that recovered data should always be stored on a different device. Failed flash drives should never be trusted for future storage because underlying hardware issues may remain. Today's recovery demonstrates how an apparently dead 8 GB pendrive can still yield valuable data through professional chip-off recovery techniques. The key lesson is simple. If a flash drive becomes unreadable, avoid repeated plugging and unplugging, avoid writing new data, and avoid risky DIY repairs. In many cases, the NAND memory still contains recoverable information, but improper handling can make recovery much more difficult. If you enjoyed this recovery case study, don't forget to like, subscribe, and share the video. Thank you for watching, and we'll see you in the next recovery project.